Okay, so you've sent over this really interesting stack on WebR. So
Yeah.
clearly something you're keen to get into.
Yeah, definitely.
And I get why. I mean, for anyone using R, the whole idea of maybe ditching the server headaches, the deployment nightmares, it sounds pretty appealing.
Oh, absolutely.
You know, those traditional hurdles, setting up RStudio server, worrying about cloud costs, or just wanting your R stuff to work on like a tablet or something.
It's a real pain point for a lot of folks in data science. Just getting access, deploying things, it involves quite a bit of overhead, infrastructure, time, effort.
Exactly. So our mission today, let's unpack what WebR actually is and how it uses this technology called WebAssembly, which sounds fascinating in itself. We'll look at the benefits. Some are pretty surprising, actually, and how it might genuinely simplify your analytics, your presentations, even how R is taught.
Right.
Think of this as your shortcut to getting up to speed on a really cool advancement.
And yeah, we're basing this on that detailed presentation you shared. So we've got some practical insights, some pretty surprising facts straight from the source material.
All right, let's dive straight in then. So WebR, the basic idea, the core concept. It's R, the programming language, running directly in your web browser.
That's the gist of it, exactly. Yeah. No need for a separate R installation on your machine. No need for a remote server that's always on just to run some R code. Imagine that.
That's pretty liberating.
And the tech making it happen, the engine here, is WebAssembly. WebAssembly for short.
WebAssembly, okay.
Think of it like a compiler for the browser. So instead of the browser reading JavaScript line by line, WebAssembly lets languages like R or C++S or Rust get compiled down.
Compiled into what, exactly?
Into a kind of low-level binary format, like optimized machine code, but specifically designed for the web browser. So you get almost native speeds right there in your browser tab.
Wait, hang on. The sources mentioned something called Fluffer, an application.
Haha, yeah, that's the name they used.
Okay, and it saw 95% performance improvements on its slowest pages when it switched to WebAssembly. That seems huge, especially for the slowest ones.
It is huge. Yeah, the experiment highlighted exactly that. 95% of the slowest pages got faster with WASM. So it's not just making fast things a tiny bit faster.
It's fixing the real problems.
Precisely. Right. It's rescuing the really sluggish parts. The comparison they showed was pretty stark. Blue for native JavaScript, orange for JS in the browser, and then this bright green for WebAssembly. WASM was clearly way more efficient, especially where things were really dragging before.
So if WebAssembly is running R natively, does that mean JavaScript is, like, going away?
Yeah.
Or how do they work together?
Good question. No, not at all. WebAssembly isn't really a language you write in. It's more a target you compile to. It runs the heavy computation, the R code in this case.
Okay.
But it can't directly mess with the web page itself, buttons, text boxes, that sort of thing. That's still JavaScript's job.
Oh, so they're partners.
Exactly. JavaScript handles the user interface, gets the inputs, and then it can pass that information to the R code running in WebAssembly, get results back, and update the page. They work together really well.
Okay, so we've seen how the tech magic bringing R into the browser, but the real deep dive now is the why. Why does this actually matter? How is it a game changer? For me, the first thing that jumps out is no more servers.
That's absolutely one of the biggest things. You potentially move away entirely from needing an R Shiny server or some other complex backend.
Right.
You build your HTML content, embed the WebR stuff, and just put those files in an S3 bucket, Amazon's cloud storage, or any simple web hosting. Which means potentially drastically lower costs compared to running dedicated servers like Shiny, or even managing your own RStudio on AWS, which needs constant upkeep, patching, all that.
Okay, cost saving is huge, but what else? Does it change the kind of content we can make? Is it just static reports loading faster, or is it more interactive?
Oh, definitely more interactive. You can create really rich, dynamic documents, presentations, notebooks, where the user can actually run the R code, tweak parameters, see results update right there on the page.
And that works anywhere, like on a phone.
Yeah, that's the beauty of it, especially for mobile or tablets, because the R code runs in their browser. You don't need a powerful backend somewhere. The content becomes truly portable, no special apps needed.
That shift, running it client-side instead of server-side, does that also help with making things more like portable apps? You mentioned containerization, sandboxing.
That's a really neat side effect, yeah. Because it runs inside the browser's security sandbox, the R code is isolated from the user's actual machine.
Like Docker does on a server.
Kind of, yeah. It gives you that isolation. Good for security, but also good for consistency. Your R code runs the same way, regardless of what's on the user's computer. It simplifies distribution, cuts down on those, well, it works on my machine problems.
Okay, that makes sense.
Yeah.
But the area that seems incredibly exciting, at least to me, is education.
Oh, absolutely. It's fantastic for teaching. Imagine students learning R or stats. They can follow along with examples, run code snippets live, right in the browser window as they read the material. No installation hassles. No, is R set up correctly?
That lowers the barrier significantly.
Massively. The sources mention this Life Data Science Conference workshop on survival analysis. Quite complex stuff like LPTR modified treatment policies.
Wow.
And they ran the whole workshop using WebR. Students could engage with these really advanced topics directly in their browser. That's powerful.
And just for sharing stuff generally.
Yeah.
Collaborating, it sounds easier. Like instead of explaining how to set up a whole shiny environment.
Exactly. You just send a link. Okay, sure, you could run it locally on your machine to quickly show a colleague, but then it's gone when you turn your machine off.
Right.
But the simplicity of just putting the files in an S3 bucket and having a live interactive website up and running, that's a huge convenience. It really helps democratize getting R-based insights out there.
Okay, I'm sold on the potential.
Yeah.
So how do you actually do it? What's the setup? Is it complicated to get started?
Surprisingly, no. The basics are quite smooth. You'd typically start by creating a new Quarto project in RStudio.
Okay, familiar ground for many R users.
Exactly. Then, once the project is set up, you run a specific command in the terminal just once to add the WebR extension to that project.
And that just tells Quarto in RStudio, hey, we're doing WebR stuff here.
Pretty much, yeah. It hooks everything together.
And the project itself, it uses the standard Quarto website structure.
It does. So you'll likely have an index file, probably index.qmd, where you write your main content and your R code chunks.
Right.
When you hit render, Quarto builds everything and puts it into a docs folder. That docs folder contains your complete website, HTML, CSS, JavaScript, and the compiled WebR components. Ready to upload.
Ready for S3 where, okay, but that data, how does data get in? If it's running in my browser, it can't just read files off my C drive, right?
Correct. Good point. It operates within that browser sandbox, a sort of virtual file system. So no direct access to your local machine or a traditional backend database.
So how then?
Usually you load data via an HTTPS URL, maybe point it to a data file stored in another S3 bucket or a public data repository online.
Okay.
Or the data could be bundled inside an R package that WebR knows how to access. It works a lot like you would in a regular R Markdown or Quarto document where you're often pulling data from the WebR packages anyway.
Got it. And managing the R code itself, the packages you need, like dplyr or dgplot2, how does WebR know what to load?
Right. Inside your Quarto project, there's usually an extensions folder and, importantly, a YAML file for configuration.
YAML, the config file format.
Yeah, that YAML file is where you set up WebR options, maybe specify CSS for styling, and critically, you tell it which R packages to make available using a line like filters.webr, and then listing packages like Palmer Penguins, dplyr, ggplot2.
Yeah.
Then your actual R code just goes inside standard Quarto code blocks, like R chunks, but they'll be executed by WebR in the browser when someone views the page.
That sounds really slick for sharing. Yeah. But what if analysis is sensitive? I don't want my interactive R report just sitting out there publicly on S3. How do you lock it down?
Yeah, that's a really important consideration. You don't always want things public. The recommended way is to use Amazon CloudFront.
CloudFront.
Yeah.
That's the CDN, the Content Delivery Network.
Exactly. You use CloudFront in front of your S3 bucket and you combine it with pre-signed URLs.
Pre-signed URLs, what do they do?
They basically allow you to generate temporary, time-limited links to your content. So you can give someone a link that only works for, say, the next hour or until tomorrow. After that, the link expires.
Okay, so even though the files are technically in S3, only people with a valid current signed URL surged via CloudFront can actually access them.
Precisely. It gives you that layer of access control.
How complicated is that to set up? Sounds like a few moving parts.
It's definitely a few more steps than just public S3. You need to create the S3 bucket, obviously. Then you generate an RSA key pair, maybe using a Python library like cryptography.
Okay, keys involved.
You upload the public key to CloudFront. You sync your WebR docs folder content to S3. Then, when you want to share, you use your private key to sign the URL for your CloudFront distribution, adding that expiry time.
You have to remember to clear the CloudFront cache if you update the site.
Yes, that's crucial. CloudFront caches aggressively for SPADE. If you render changes and push them to S3, you need to tell CloudFront to invalidate its cache. Otherwise, people will keep seeing the old version.
Got it. Okay, so This all sounds incredibly powerful.
Hmm.
Which brings up the question, why isn't this WebAssembly thing and WebR just everywhere already? What are the catches, the challenges?
It's a fair question. One thing we mentioned is that WebSummit itself can't directly manipulate the web page elements. It needs JavaScript for that UI interaction piece. So it's not a total replacement, it's a partner.
Right, so it adds complexity maybe, needing both.
Potentially, yeah. And the other big one, specifically for WebR, is compiling the R packages themselves for WebAssembly.
Ah, that sounds like the tricky part.
It really can be. The source material called it a potential rabbit hole. Package dependencies in R can get complex, sometimes reaching back to, like, old Fortran code.
Fortran.
Yeah. So compiling all that intricate stuff reliably into WASM is definitely not a simple thing, as they put it. It takes real effort and expertise.
So it's not like you can just take any R package off CRAN and expect it to magically work in WebR without some effort.
Not necessarily, no. Someone, somewhere, likely needs to compile it and its dependencies specifically for the WebR environment first.
But is that happening? Are people doing that work?
Oh, yes, definitely. There are community efforts and repositories popping up with precompiled R packages ready for WebR. That helps enormously. You don't have to build everything from scratch yourself.
Okay, so the ecosystem is growing. That's good. You know, one thing the sources didn't seem to have, which I'd love to see, is a direct performance shootout. Like our code running in WebR versus native R on a laptop versus an R Shiny server. How do they actually stack up?
Yeah, that's a great point. Understanding those specific performance trade-offs across different scenarios, computation heavy, lots of data transfer, UI intensive, that would be super valuable. Where does WebR shine, and where might, say, a traditional Shiny server still have an edge? It's a key comparison for people deciding how to deploy.
Absolutely. Okay, so let's try and wrap this up. The big picture with WebR seems to be it takes R, brings it right into the browser using WebAssembly,
Right.
which dramatically simplifies sharing and using R content. For many cases, you can ditch complex server setups.
Cuts costs, reduces maintenance headaches.
Opens the door for really interactive, portable content, especially good for mobile and tablets. And it looks like a game changer for education.
Huge potential there, lowering the barrier for students to just start doing R.
And while there are hurdles, like package compilation, the ecosystem is developing, and you can even secure content using things like CloudFront.
Exactly. It's lowering barriers, making R more accessible, putting powerful analytics right into a browser tab.
So the final thought then, for everyone listening, considering all this, how could you use this? Could WebR help democratize data analysis where you work, make it easier for colleagues to engage with R?
Or could you build more dynamic, hands-on teaching materials? Let students experiment directly.
Maybe just streamline how you share your own analyses. Get insights out faster, more interactively. What possibilities does having R in the browser really unlock for whatever you're working on next?